Hi everybody. In the most recent video, we went through a little example of how to calculate a one sample t-value. Now we're going to finish that scenario by interpreting the t-value that we calculated. So just as a quick recap, of course, a one sample t-test is appropriate when you have a sample of people and they all belong together in the same group, and then you want to compare their information, their mean and standard deviation essentially, to some set criterion, something that you decide you want to set. So in our scenario, we had a guy named Hector who was interested in churchgoers that were in his congregation, and he wanted to see if they had different amounts of credit card debt than the national average, which is $6,500. Now, just a little scenario here to try it out. Now, as you'll recall, he had 11 people in the sample, and he found a t-value of negative 0.12. Again, if this is news to you, you can go back and see the video right before this one in the playlist. One of the first things we need to do to start interpreting the result of a one sample t-test is we need to find out the degrees of freedom appropriate for this test. Now they're calculated a little bit differently than we would do for an independent samples t-test, but it's very similar to a dependent samples t-test. So let's take a look. We calculate the degrees of freedom by taking the total number of times we observed a value for the dependent variable, and then we subtract 1 from that. In this case, because the units of our observations were people, they were people in the congregation, we can just take that number, and as long as we had an observation of the value for every one of those people, we can just subtract from that. In this case, we had 11 people who were the churchgoers in this congregation, so we're interested in 10 degrees of freedom. Because there were 11 people, we take 1 away, now we have 10 degrees of freedom. Pretty straightforward. Once we have our degrees of freedom, we can now find out our critical value, or the critical t-value. In other words, the critical t-value is the lowest possible value of t for a test with these characteristics, the degrees of freedom specifically, that would be considered statistically significant. In other words, it's saying you need at least this value, positive or negative, or more, in other words, farther away from 0, to say that you have a statistically significant result. In other words, to say that your group's mean that you tested is actually different from that standard that you set. Okay, so that's essentially what we're doing here. If we calculated a t-value, our negative 0.12, that is farther away from 0 than our critical value that we're about to figure out, then I can say that our group actually did differ in their average credit card debt from $6,500 on average. Okay, so let's find that critical value. Once again, we need to go to Appendix B in my textbook. If you don't have my textbook, that's okay. You can just Google this. You can search on the internet for a t-distribution table, for example, is a good search term. And there are all sorts of ones out there that you can check out. They're mostly similar. Shouldn't be too difficult from what or too different from what I'm about to show you. So here's what it looks like in my textbook. My Appendix B looks like this. And of course, we're looking at only the left side of the table because we're interested in the two-tailed criterion. Once again, this is because Hector left it open to both possibilities. He wasn't sure if he would find the difference as higher than the national average or as lower than the national average. He just wanted to know where the difference was. So for that reason, this is a two-tailed test criterion that we're using. So we're just looking at that left side of the table here. And of course, this is the degrees of freedom. As we just said, in this particular case, Hector had 10 degrees of freedom because he had 11 observations of the variable, and 11 minus 1 is 10. And we're curious about only the 0.05 level of significance at this point, because that is sort of the maximum threshold of the error rate, the type 1 error rate, that we're going to allow. And that's exactly what this means. In other words, we're allowing a 5% possibility of error if we reject the null hypothesis. But only if we exceed this criterion, obviously. So 2.228 is our critical value, okay, as you can see here. So once again, a critical value of 2.228 means we need to find a t-value at least that far away from 0 before we can say that there's statistical significance, or before we can say that we found a meaningful difference between our sample and the criterion, the test criterion that we set, which was 6,500 in this case. Okay, now we did not find a t-value that was that far away from 0. The t-value we calculated, as you'll recall from the previous video, was negative 0.12, which is much closer to 0 than 2.228 positive or negative. And so therefore, we are at the point where we can say this is a not statistically significant finding or a non-significant finding. We therefore retain the null hypothesis, and we continue to assume that the mean credit card debt in our sample did not differ from 6,500. Okay? In other words, we have no reason to believe that our sample actually differs in terms of credit card debt from the national average in credit card debt. So now at this point, I'll just summarize our findings. So once again, we had a one sample test. We wanted to test whether people in this congregation, this particular congregation of churchgoers, differed in credit card debt from the national average. And the known national average was 6,500 based on some real data. So that was the criterion we set. And what we found was a non-significant difference, meaning essentially we can't say that they're any different at all from the national average. Then again, in APA format, I present the results in this manner. The t-value with 10 degrees of freedom was negative 0.12, and the probability of committing a type 1 error by rejecting the null hypothesis is greater than 5%. Therefore, we do not reject the null hypothesis because that would be too high of a risk, is essentially what that's saying. Now, we don't really have any reason to believe that this congregation is different from the national average, as I said, because we did not find statistical significance. Okay, now at this point, generally we would calculate the effect size and then the confidence interval. You don't really need to do that. I mean, there's not a whole lot of justification for doing that if you found a statistically non-significant difference. You can do it just as an exercise. That's certainly okay. Or if you want to find out a little bit more about the sort of strength of the relationship, that'd be all right. In fact, particularly in this case, I thought that we had kind of a large standard deviation in our particular sample. That might be something to look at with confidence intervals and just see if the confidence interval was overly wide, perhaps, even though it for sure included 0. We know that at this point because it wasn't statistically significant. It might be just a nice little exercise. In any case, we're going to go ahead and calculate the effect size using these data and the confidence interval in the next video, just so you can see how that's done for a one sample t-test. I'll see you then.